Okay, so today I'm going to be going over this worksheet that says an introduction to writing ionic and covalent compounds. And I just want to go over a couple things before we get started. There's some rules here. First off, make sure that we're using the crisscross method to find the formula, using the valence electrons. So an example of that would be if we have sodium, which is a +1, looking at the periodic table. And then we have oxygen, which is a -2. The crisscross is going to give us Na2O. Okay, you always write the metal first and then the nonmetal. Then to name this is going to be sodium oxide. So you write the metal first, change the ending here to oxide. For the transition metals, this is important. You need to add the Roman numeral. So for iron, if we take a look here, here are some transition metals here. I'm going to zoom in. I'm going to post this also in the classroom. We have iron 2 and iron 3. That gives us a +3 charge, iron 3. So you always want to make sure that you're using the right, the Roman numeral. And we don't really use ferric or ferrous or plumbic. These are all kind of really, they're old-fashioned. It's those are Greek words. Okay, so let's see. This should be iron 2 plus oxygen. So what I know from this is that this is going to be Fe +2 and oxygen -2. The crisscross, these are going to basically just cancel each other out. So we're going to have FeO2, and this is going to be iron 2 oxide. Okay. A couple other rules to keep in mind, and this also goes for when we are using polyatomic ions. And polyatomic ions are going to be those that are a multi-thing. So we have things like chlorite here. We have chlorate, carbonate here. When we are naming those, we want to make sure that we are keeping that ion intact. Okay, so I'm going to show you. We have carbonate, which is CO3 -2, and let's just say that we have lithium added to that. Okay, lithium's a +1. So when we go through and crisscross, that's just going to be lithium Li2CO3. Now, let's pick one that has where it would change. Let's see. Let's take a look here. Let's do chlorate. Okay, Cl O3-. So Cl O3 -1. And we're going to do magnesium chlorate. Okay, when we do the crisscross method, we got to make sure that we keep the ion intact here. Okay, oops, did not mean to erase that. So we got to keep that ion intact. So what we're going to do is we're going to write this as Mg parentheses ClO3 2. Okay. That way we know that there are 2 of this ion. And this would just be magnesium chlorate. And you just write the name of that ion. All right, so let's take a look at covalent compounds. So covalent compounds, you're going to still use the crisscross method. We're going to still keep in mind that these polyatomic ions, make sure we have the parentheses to maintain that ion. And what we're going to do is the first thing is we are going to name the element. We write the formula and name it with the element that's farthest to the left or to the bottom of the periodic table, and then the element to the right or the top of the periodic table. Okay. So with this one here, we have this is where the crisscross method really helps to make things a little easier. So we know that nitrogen is in group 5, so it needs 3 valence electrons to make it happy. Oxygen is in group 6, so it needs 2 electrons. So keep in mind that these numbers here, these are how many electrons they need to gain to get a full octet to get to 8. When we crisscross, we end up with this formula here, N2O3. We're going to be using the prefixes dinitrogen trioxide, okay? In general, the only time you use the mono is if it's in the second element. An exception of that would be we could do carbon monoxide. We could kind of leave that there, okay? So let's go back to the worksheet here, and we'll do a few of these together. All right, so this is just making several formulas here. Now, it's really easy to see if it's a +1 and a -1, it's just going to be the formula. NaCl. That's pretty simple. This again, NaNO3, okay? Remember, we want to maintain that. So going along through all of these, you can see that, okay? So I think these are pretty straightforward. Here with the NH4, again, you want to keep the parentheses. So these first ones are going to be pretty simple. It's just going to be sodium. It's going to be NaNH4, okay? Those are going to be pretty simple. Here, what we're going to have is we have this 2 here. So we're going to do NH4 parentheses, hello, and put a 2 there and an S there, okay? Same thing here, NH4, oops, 2CO3, okay? Kind of running out a little bit of room. So you can see how that works, okay? Now, moving down here to this one, to Hg2 + 2, this is mercury. And what we're going to do is we'll do the mercury, we'll do this one right here, the mercury nitride. And so what we're going to do is I'll write it right here, Hg + 2 and N + 3. We crisscross that, so that should be Hg 3 N2. I got to check this one. I think that 2 right there is a typo. Okay. Here we have, let's do this one down here. We'll do the SN4. So one thing you want to kind of keep in mind is make sure that you're in the simplest format ever. So I'm just going to write it underneath here because I don't quite have enough room. So I have SN + 4, and then I have CO3 - 2, okay? What I'm going to do, if I crisscross these, I could divide both of these by 2 just to simplify it. So then I have SN2 + 2, and then CO3. And so then this is going to equal SN parentheses CO3, and then add the 2 there, okay? So just kind of keep in mind, if you're able to reduce that, do that. Next, taking a look here, naming ionic compounds. Again, you're going to be making the formula and the name. Here you have copper + 2. And if we look at our chart, we see that copper is one that we have here that is a +2. So we want to make sure that we use that parentheses. We'll go back here to this page. So this is going to crisscross that, and so it's going to be don't use that highlighter there. That's going to be Cu parentheses OH, because we want to maintain that ion, 2. And then when we name it, it's going to be copper, Roman numeral 2, hydroxide. Okay, so just take a look at your ion list, make sure you do that. This one here, down here, iron 3, okay? Now, if it's something like barium here, that's a +2, that has only one answer, so you don't have to worry about adding the Roman numeral. It's just those transition metals that are on your list. Okay, we're going to go over to the back page here for some nonmetal compounds. So we do not use, for the nonmetals, I want you to keep in mind, we do not use the mono here for the first element. We're going to be writing this just as it's looking. We're going to use the formula here to kind of guide us, to tell us. So nitrogen trifluoride. So again, we have Na. Okay, me having a little difficulty here. Okay, so we're going to have nitrogen, N is a -3, F, okay, it's going to be just NF3, okay. This is going to be NO, nitrogen monoxide, and this one is going to be nitrogen dioxide, NO2, and so on, okay. Xenon tetrafluoride, that's a fun one. Okay, so naming binary nonmetal compounds. So here's our formula, CCl4. You're going to call that carbon tetrachloride. And here P4O10, so that's going to be tetraphosphorus decaoxide. Okay. For this bottom type for both names, again, naming most of these. One thing you're going to see here, so HCl, it's actually one of our strong acids. So you would call that hydrogen monochloride. We actually are just going to learn that this is going to be hydrochloric acid. Chloric acid, okay? So the regular naming rules are going to be a little different because that's one of our strong acids. Here we have the next one here, we have phosphorus, pentachloride. We do not, remember that we do not use the prefixes for ionic compounds. Okay, so if there's a metal, it's just going to be the name of the metal and sulfide. Okay, or in this case, nickel sulfate and throughout. Okay, and that is kind of how to name that. I'm going to post some of this information, these charts that I have here. I will add those to the Google Classroom so you can take a look and let me know if you have any further questions. Bye.